Hello, my name is Jens and we are guests at Shure Distribution in Eppingen, Germany, and I want to show you a little bit about our wireless network system called Axient today, and I will show you what this system can do for you. A little philosophy at the beginning why we have this system. We see that the worldwide spectrum is shrinking. More and more mobile devices need more band to have wireless internet everywhere, so we see big parts of the spectrum go away. So we have a shrinking spectrum and we need wireless systems that can do many channels in a small spectrum. That's one part. The second part is that in this smaller spectrum we will see in the future more and more interference, because smaller spectrum, many devices, so there will be a lot of interference. And that's the second big part of what Axient can do. It can detect interference and also move away from interference. And I want to show you how this is working and how this can be done. Very basic for Axient, as with any other wireless system, you need transmitters and receivers, and if you tune a transmitter to the same frequency than a receiver, then they will work together. Now, to be able to detect interference and to move away from it, we need a few extra devices. First of all, I show you the interference detection. This is a technology that is built in a receiver, and I show you how this works. If I have my microphone here and I have a little interferer here that I will interfere with, and now you see the display turns red and we get an interference message on the display, and also on the connected computer you'll see a pop-up. So this is interference detection. So we have the possibility to detect interference even before we actually really hear it. So now the receiver gives me a couple of options, and a really cool option here is switch. So if I hit switch, the display says interference resolved, and I moved away from this interfered frequency, and as you can see, the transmitter followed. So there must be a link between the transmitter and the receiver, and it is consists of two parts. One part is built into the transmitters. There are 2.4 GHz transceivers inside. We are using Zigbee technology, and the other end of this is what we can see here. So what we called ShoLink access point. This device is connected via Ethernet network to the rack, and all the devices in the rack are networked together, by the way. And through this network, the receiver has connection to the transmitter. So the receiver talks into the Ethernet. This device converts this to 2.4 GHz Zigbee, and we have so a wireless link between the receiver and the transmitter. And this link does what you've just seen. If you do it and change on any of the devices, the other device will follow. So if I change frequency here, the transmitter follows. So I can also manually do this, say get me a new frequency. So now the frequency changed, and can do it again. And you see there's hardly a dropout. There's a little dropout, but it's very short. Okay, so we have the capability of interference detection, and with the ShoLink we can also switch frequencies or change frequencies, because these devices are networked together. The question is, where does this frequency come from? Where or how does the receiver know which frequency it should change to? And there's another component that's new, that is the so-called spectrum manager. The spectrum manager is in the rack down here, and it looks very similar to a receiver, but it's missing some LEDs, RF and audio LEDs, but it looks very much the same. What it does is it automatically scans the spectrum through the same antennas than the receivers are connected to. So they are all hooked up together over an antenna splitter here. And so it uses the same antennas than the receivers. So we get real scan data. We see the same spectrum than what the receivers see. And with this scan data, it takes approximately a minute to scan the complete UHF spectrum, 470 to 865 megahertz. And with this scan data, the spectrum manager calculates frequencies. And it doesn't only do this for Axient devices, it does do it for all devices from Shure that have a network plugged to it. So for example, PSM 1000 or ULXD or UHFR. So, and on top of giving these devices frequencies, it also calculates backup frequencies. And when it's done calculating, the spectrum manager looks at these backup frequencies. So the spectrum manager knows exactly how many backup frequencies are good, how many are bad. So in the moment we need a backup frequency, the spectrum manager makes sure that it's a very good frequency, it's free of interference. Because if you want to make a frequency change, you want to make sure that the frequency you change to is a clean and good frequency. So all this together, we have interference detection in the receiver. We have a backlink from the receiver via this access point to the transmitter, so they can talk to each other. And we have a frequency server down here, the spectrum manager, that does the calculation of the frequencies and also takes care of the backup frequencies. So in case of interference, it's detected and I can switch frequencies. So why not doing this automatically? It can be done. I have to do a little adjustment here, change the interference detection to automatic, and I'll do the very same thing. I'll interfere with it with another transmitter, 718650. So and if I interfere with it, you see the display turned red and it says now interference resolved. Automatically the receiver changed to a new frequency. So when the interference came, the receiver noticed, oh, I have an interference problem. It told the spectrum manager, give me a new frequency. The spectrum manager provided its best frequency. The best frequency was sent over Zigbee to the transmitter, and when both devices were ready, the frequency was changed. This whole process takes maximum 500 milliseconds, and you will hear a brief dropout when this happens. If we now say, okay, very cool, but this little dropout is not acceptable. Then there is another new thing in here that is called frequency diversity. We know diversity from antennas. We have two receiving antennas here. That's a known technology. So every receiver has two antennas in case of multipath or other effects. One antenna might have a weak or bad signal, then the other antenna takes over. That's a known technology. Now we have frequency diversity. That means the transmitter transmits on two frequencies at the same time. So let me activate this and let's take a look at what the receiver then looks like. So I have to synchronize via infrared one more time to tell the transmitter that it should transmit on two frequencies. And now you see this one double receiver is now tuned to the two frequencies I transmit from the transmitter here. So we have the same signal on both sides, and every output of this receiver now has the same signal, and it's the signal that the receiver chooses for us. So now let's go one step back and let's interfere with it and not do the automatic frequency change. So I again interfere with my left side here, 727. And you will see what happens. The receiver detects the interference on the left side, but you won't have a loss in audio because now the right side frequency takes over, and the receiver automatically picks and chooses the best and optimum frequency for us. And if we now combine what we just had before, I hit ignore here, and I turn on the automatic here again, and I do the interference again, you will see that we have interference, and the interference is automatically resolved within a few 100 milliseconds, and now we are on 2 clean frequencies again. And this all happens without interruption of the audio, seamless audio when you are in frequency diversity. Frequency diversity is also possible with body packs, but there's a little difference. The body pack can only transmit on 1 frequency, so if you want to have frequency diversity with body packs, you need 2 body packs on your talent, and there are a couple of ways to do this. You can have 2 microphones, or you can use a Y cable and have 1 microphone element and transmit it on 2 frequencies. One more device that is new to wireless systems is the antenna combiner down here. It has 2 options that are also needed in demanding wireless environments. And one thing is filtering. This device can filter with band passes the frequency range that our wireless system operates in. So you can choose from a couple of different filter settings in here to optimize the performance of your system. Another thing is you can also add a little gain or a lot of attenuation to your antenna system. This is necessary if you have a lot of interference in your spectrum. You don't need the maximum range of your system, then it makes sense to add attenuation to your antenna system to get you more clean frequencies, and that can very easily be done through the menu down here or through the PC, and you can add additional attenuation to your antenna system in order to have more clean frequencies. That's pretty much it. For now, thank you and goodbye.